in this problem we need to find out the probability of obtaining exactly m heads when a coin which is unbiased is tossed exactly n times. First of all, let us assume that in the first m tosses of the coin we obtain all the heads, and in the rest of n minus m tosses we obtain all the tails. Then we can write simply is equal to 1 upon 2 for the first toss, the probability of obtaining a head, into in the second toss the probability of obtaining a head, and so on, into in mth toss the probability of obtaining a head, into in 1 upon 2, which is representing the probability of obtaining a tail in the m plus 1th event, and similarly 1 upon 2, which is now the probability of obtaining a tail in the nth event, which simply equals 1 upon 2 to the power n. So we can see that the probability of obtaining exactly m heads in the first m events or first m tosses is 1 upon 2 to the power n, but in this problem we do not have to find the probability of obtaining heads in the first m events, but we have to obtain the probability of obtaining exactly m events when this coin is being tossed exactly n times. That means these m events in which we obtain heads are not necessarily those events which are the first m events, but they can be chosen from any of these n events, and we can simply see that the number of ways in which m events can be chosen from n events is ncm, which equals factorial n upon m factorial. Now this is the total number of ways we can choose the m events out of the total n events in which we obtain heads, but in each case we will have the same probability, 1 upon 2 to the power n, and therefore is equal to 1 upon 2 to the power n into factorial n upon factorial m into n minus m factorial, and this is option number 3. Therefore option number 2, therefore the option number 2 is true.